So in this video, we are going to look at how the formula for surface area of cones and pyramids, how those formulas are derived. So this picture might look a little confusing at first, so I'm going to explain all the pieces. This is what a cone looks like. If I were to cut that apart and make what's called a net, my two-dimensional representation of the cone, the curved part of the cone looks like this. So cones, for example, if I have a really wide, fat cone, I'm going to get, it probably looks like almost a circle, kind of like a Pac-Man. If I were to take that and then fold these two pieces here together, I form this part of the cone. And then there's a circle that would get glued to the bottom that is another surface for that cone. And the distance around this circle is matched up with the distance around that portion of a circle. The circumference of the bottom circle equals this portion here. The skinnier and taller that the cone is, the smaller. So if I had a cone that was more like this, then it might be a piece of a circle that was more like that. And then again, I'm going to have that circle, and the circumference around that circle will be the same as the distance around the portion of my circle that forms this part, the lateral surface of the cone. So let's go back to this picture then. So in this picture, a couple of things to note then. S is called slant height. The reason why we have a different letter, we can't just call it H, because H is the height of the cone, and that's actually there. So the height is actually just the distance when it's on a table, from the table to the top point, to the vertex. So we have to call this lateral height something else, and we call it slant height. The radius, you guys are all familiar with that. And so when we look at this portion of the circle, which again, as I explained to you, is this lateral surface part of your cone, we're going to be looking at some labels on it. So the radius of the lateral circle part is actually the slant height. If you look at that, the radius, this represents that right there. Then the distance here, remember how I just said that the distance there is the same as the circumference of this bottom circle? Well, the circumference of the bottom circle is pi times diameter, or another way of saying that is 2 pi r. So that's why this is labeled 2 pi r. Now I want you to picture this portion of a circle, and I want you to picture cutting it into tiny little triangles. When you cut it into tiny little triangles, what you can actually do is stack the triangles one on top of the other, like this, to form a rectangle. Because it's really hard to find the area of a portion of a circle. We know how to find the area of a circle, it's pi r squared, but the area of a portion of a circle is very difficult. If we cut these into little triangles and use those to form a rectangle, we can now find the area of this shape. Keep in mind, however, that the distance around was 2 times pi times r. When I cut these up, and basically it takes two triangles to make one little rectangle, the distance across is no longer 2 pi r, but is 1 pi r, because it took me two triangles. So this is going to be double that. But the radius is still the slant height, so the height of my rectangle is still the slant height. So if we keep that in mind, what would the area of this rectangular shape be, which is the same as the lateral surface of the cone? Well, that would just be pi rs, because it's length times width, or base times height. Then, for a cone, that's going to represent this lateral part, so this part that I'm coloring in green. But there's another part of the surface of a cone that we need to think about, and that is the circle that's on the bottom of this cone. And that, because it's a circle, is pi r squared. So that is the formula for surface area of a cone. Keep in mind that if that cone, let's say, was an ice cream cone and didn't have this circle, or was like a drinking cup and didn't have this circle, then you wouldn't include this part in your calculation. So you have to read each question really carefully to see what it's asking you for. So let's go on and look at an example of how we can actually use that. Now, before we can look at an example, we were introduced to this term slant height, and that would be right here. And then height would be here, and radius would be here. And so what you have to be able to do is work between all of those measurements, because sometimes you're not given all of those things. Well, if you look at this picture, what have we formed right here? Hopefully you can see that we have actually formed a right angle triangle. And hopefully your brain's going, oh my gosh, right angle triangle, I could use Pythagorean theorem. So Pythagorean theorem, remember, if here's my right angle triangle, is a squared plus b squared equals c squared, I can translate that or adapt that to these letters, because the letters don't really matter. So I could say that slant height squared was height squared plus radius squared. Likewise, what if I was given height and I needed to find the slant height? I could say that height squared is slant height squared minus the radius squared. So these two formulas can be used, or I think I said, what if I was given height and I need to find slant height? You would use that one, but what if I was given slant height and I needed to find height? You would use this one. Most of the time you're going to be given radius, but you're probably not going to be given both the height and the slant height. So you're going to have to use one of these formulas, which is just an adaptation of the Pythagorean theorem to be able to find a missing side. So now let's look at an example. So here says find the volume and surface area of the cone. So you've already learned that volume of a cone is your cylinder, pi r squared times height, divided by 3. So now all we have to do is substitute. Now it gives us diameter, but we know that if the diameter is 10, the radius is 5. And they give us our height, and we divide by 3. All we have to do is punch that into our calculator. When you punch it in, I would recommend doing pi times 5 squared times 12, hitting equals, and then dividing by 3. And we're going to round to, let's say, 1 decimal place. So we get 314.2, and volume is meters cubed. So that was pretty straightforward. But let's find the surface area. A little bit more challenging. So our formula is pi rs, which is the lateral part, plus pi r squared, which is the bottom circle. Now we don't have s. It didn't give us s, so we need to use Pythagorean theorem to find that. So how are we going to find s? We have to take height squared and add radius squared. And what I want you to do is I always want you to round this one to 1 decimal place, just for ease of having consistency with our answers. If we all round to 1 decimal place, then we're all going to have the same answers. Now this one happens to work out. So s squared is 169. Remember, how do we get s from that? We have to square root. So this one is going to work out to be a whole number, but if it didn't, I would like you to round it to 1 decimal place. Now that we have slant height, all we need to do is substitute. That's really the easy part. All we need to do is go to our formula and just put in the things that we know and do our calculation. So we do pi times 5 times 13. One thing, when I say that I want you to round to 1 decimal place, what you typically do in your work step is go to more. So you maybe go to 2 or even 3 if I ask you to round your final answer to 1. So make sure you don't round your work to 1, because if you round too soon, it's going to throw off your answers, and they're actually not going to be as accurate as they could be. So I always recommend going to at least 1 more place than what is asked for in your work, potentially 2 more. So this will work out to be 282.744, so now we can round it to 0.7, and the units are meters squared. So that's just a introduction to the surface area of cones. And then the next video is going to look at pyramids.